Okay, in this part, we're looking at a more complicated trig equation, but it's complicated in a different way. The insides are nice and simple. What's being strange here is that we have a trig function being raised to a power. Now, since this is a trig function being raised to a power, we call this a nonlinear trig equation. We actually saw equations sort of like this much early in the semester. We call these equations of quadratic type. Now, let me show you, I'm going to use the word blob again, just so I can. That's right. What I see here, I see 3 blob squared minus 7 blob plus 2 equals 0. Now, if this said 3x squared minus 7x plus 2, we would just factor by unfoiling. And that's the right intuition. So as long as you can just recognize the pattern here and see that we see 3 something squared minus 7 something plus 2 equals 0, we should be able to factor this the same way we do this when we just factor from plain old algebra. So what I would want to do, we're just trying to unfoil because that's what the intuition we're trying to build on. I want to have 3, I want tangent t here. This would have to be tangent t because these two things multiply together give me 3 tangent squared. I know it's minus, and I'm thinking it's 2 and 1. I think that works. That's minus 6. It does. It works. Now, what do we do next? We now use what's called the zero principle. This is the same one they use in algebra. When I multiply two things together, they get 0. One of them had to be 0. So we set this one equal to 0. We set this one equal to 0. And then we just solve each piece. When I set this one equal to 0, what I get is tangent t equals 1/3. Well, we know exactly how to solve that. Let's just finish this the way we would before. Remember the tangent's slope. So what we would want to do, just so we have some intuition, is we now want to draw a circle, draw a line through the origin whose slope is 1/3. It goes up pretty slow. So I get something like that. And then we need that value and that value. 1t we can get by using inverse tangent, and I guess I'll just say inverse tangent here is inverse tangent of 1/3. I'm still trying to maintain a little space here. So I'm just going to go over my calculator. I'm going to say the inverse tangent of 1/3. I'm betting it's actually pretty close to 1/3 anyways, but we'll see. It says, it's close. All right, what I get is 0.321321750. I don't like to give up any decimal places if I can help it, but I need the other half, so I get that. Now, how about all the others? Well, what happens is we can get all the others by starting with this one. So 3217505, and then adding any number of half laps. Remember, half lap around the inner circle is distance pi. So what I'm going to get is here, let's just say, plus any number of half laps. And so we've actually solved half this problem. And I don't think I left myself quite enough space, but we'll see. What about the other one? I set the other one equal to 0. I'm going to get the tangent of t equals 2. Remember, tangent is slope, and we use m for slope. Drawing a little unit circle so I can just see what's going on. We're now supposed to draw a line through the origin whose slope is 2. Well, that's going up pretty fast. So that's going up here like this. Right, and I'm thinking that's going to be 1.3-ish. But we can get 1t by using the inverse tangent of 2. And like I say, I think that's going to be 1.3-ish, but let's just check. Going over to inverse tangent of 2, I get 1.1, so I'm off. Let's do it this way. Equals 1.107, 148.7. That's as many decimal places as I think I can squish here. What about all the others? Well, all of the others we can get by taking the 1.107, 1487. Remember, that just gives me the distance up to that first one. I can get to all the others by saying add any number of half laps. A half lap around the unit circle is distance pi, so I'm going to say plus any other number of half laps I've already used k. I don't want to use m because I've already used m for slopes. So how about if we say something like n pi, like that, right? And that's as hard as it gets. You just factor the original equation, right, to break it up into little equations that we know how to solve. And once you're really, really good at solving the little ones, and you can factor, there's actually nothing new here. Yay!